Okay, so this is, well, it says number 6, but no, it is number 6. I just, for some reason, had the next one labeled number 4. Okay, so using a 4-bit, nope. Using a 4-bit synchronous counter with parallel load, see below for inputs and outputs, and a minimum number of additional gates as needed, construct a counter that counts from 0101 through 1001, and then repeat for a count from 0101 through 1101. Okay, so what we want to look at here is parallel means that all of the digits get loaded at once. And with a counter, the counter is going to load the numbers when the load on there gets a signal of 1. So that's when it knows it's going to load the numbers. And we can assume that this counter just works. We don't have to worry about how the counter works. We did that last week. So we can just assume the counter works. So we want to start with the number 0101. And the order of these digits, so in binary, that's the 1's place, the 2's place, the 4's place, the 8's place. So you'd add up where you have the 1's. In binary, that's a 5.
Boy, it's a little bit difficult to see on
It is. Yeah, I'm used to my stuff over in Tarot. Yeah. Okay, so that's our number 0101, and that's the 1's place, the 2's place, the 4's place, and the 8's place. And so you add together where you have 1's, so it's a 4 and a 1, so that's the number 5. But also, the biggest number is called the most significant bit, and the smallest number is called the least significant bit. And so with 0101, the 1 at the end, that's going to be D0, and then D1, and then D2, and then D3. So the 01 is at the end, so 0, 1, 2, 3. So it counts in that direction. And we can assume that the way the counter is going to work is that if it starts with 5, the next one it'll get will be 6, and the next one it'll get would be 7. And so it's just going to, no, that's 6, that's not 7, 7. And the next one it would get would be 8. So it's just going to count correctly, and then the next one would be 9, which is where it's supposed to stop. So this is actually really pretty easy. So we want to start by loading the number 0101. So this first 0 goes to D3, the 1 goes to D2, the 0 goes to D1, and the 1 goes to D0. And you just have to remember that this, you actually are reading this from bottom to top. So 0101 makes 0101. Now we need to have a 1 going into the enable, just so that it works, because that's going to make it work. And then we want it to stop when we get to 1001. Okay, so when it gets to 1001, we want it to load the original number again. And so if we look at this number, if we take the AND of this digit and this digit, that's only going to be 1 when we get to 1001. If you look, none of the ones above have 1s in both of those places. So once it gets to 1001, that's the first time it has 1s in the first place and the last place. So all we have to do is take the AND of those two and connect it to the load. And so when it gets to a point where Q0 and Q3 are both 1, then it's going to load the original numbers again. And then it'll count until it gets to that number, and then it'll load the original numbers again.
Why would you want it to reset like that?
Because that's what the problem asked.
Oh, okay.
It says construct a counter that counts from 0101 through 1001.
Okay.
Yeah, I don't know why you would want that. It's just because that's what was given. Okay, and then it said the next one was to count from 0101 through 1101. So I'm going to draw my counter. So it's a 4-bit counter. That's why we have 4 D's here. So D0, D1, D2, D3, and 4 Q's. Those are the outputs, Q0, Q1, Q2, Q3. And we have a load. And I'm not going to draw the output carry. That's what we would use if we were connecting this to another counter, but we're not doing that. And there is a clock, and I didn't draw the clock. Okay, so our original number is 0101. So this is 0 in front. That's the most significant, so it goes to D3. And then 1. And then 0. And then 1. And I'll have a 1 going to enable. Oh, you can't see that at all, can you? It's like, it's acting like it's got all this fancy stuff. And now my computer.
Well, would this one be the same, but you take the AND of D2 as well?
That is absolutely correct. Yep. And then, so you take the AND. So for the recording, what he just said was, is this the same as the last one, except you take the AND of Q2 as well. So it'd be the AND of Q0, Q2, and Q3. And now I have to restart my computer. Oh, wait, maybe not.